Hi class, in this video we're going to set up R2 and R3 as routers. So when we last left off we configured R1 as a NAT router, so now I'm going to go to the second router, which is R1. Sorry I've labeled these router B, but this is R1, R2, and R3. So I'm on the second router and we're going to configure routing. First thing we need to do is install it. I'm going to go all the way down until I get to server roles, and I'm going to choose remote access. Then continue down to role services. When I get to role services, I'm going to choose routing and add the tools to manage routing. Next, it's also going to install direct access, which requires the web server. We're not going to use that function in this class. And restart if needed. It takes a few minutes to install, so I'm going to pause the video. It's done installing, so what I'm going to do now is configure it. So I'm going to close this window, go to Tools, Routing and Remote Access. There's my router R2. It's not configured. That's what the red arrow pointing down means. So I'm going to right click it and configure it, enable routing and remote access. Click next. Sorry, my cat was making a bunch of noise. On R1, we configured it as a NAT router. The router that connects you to the internet should be a NAT router. All other routers are just going to be just regular routers. They're not going to have any NAT feature installed. So in this case, we're going to choose a secure connection between two private networks. So this is going to connect subnet 1 and subnet 2 together. R1 will connect subnet 0 and subnet 1 together and also connect us to the internet. And R3 will connect 2 and 3 together. So I'm just going to choose secure connection between two private networks. And it's asking if any of those connections are a demand dial. If you remember the old AOL network, every time you connect, it would dial the network. That's a demand dial. When there's a demand, it'll dial that connection. In this case, they're two permanent connections, so we have no demand dial. Then click Next. Then Finish. Okay, so this is done. If you go to NAT, there's nothing under it, so NAT's not configured. So now I'm going to do the same thing to R3. I'm on R3 now, so I'm going to go to Manage, Add Roles and Features. Click Next, Next. Now I'm at Server Roles. I'm going to choose Remote Access. Now I'm going to keep going down to Role Services and choose Routing. And add the tools to manage routing. Restart if necessary. Click Install. I'm going to pause the video while it's installing. Okay, it's done installing, so I'm going to close this window and configure the router. So I'm going to go to Tools, Routing and Remote Access, highlight my router and right click and say configure and enable routing remote access. Click next. This is not going to be a NAT router because it's not touching the internet directly. It's this machine over here. So we're going to do a secure connection between two private networks. They're both permanent connections, no demand dial. Finish. So I'm going to go to router A. This is my routing remote access utility. So I'm going to highlight static routes. Right click it and show an IP routing table. Now this is my IP routing table. I'm also going to open up a command prompt. If I do an ipconfig space /all, I'm going to scroll up. And on my public interface, I automatically get a default gateway from my school's router. This is part of ACE-IT. You don't configure this. Our public interface is dynamic, and this is the IP that it gives us. And I see I have a gateway. If I go up to the interface attached to subnet 1, it has no gateway. If I go to the interface attached to subnet 0, it also has no gateway. So I'm going to go look at my routing table again. I have this route where the destination is quad zeros, the network mask is quad zeros, and the gateway is 0.0.0.1. That got added when I assigned a gateway to this interface. We did it dynamically through the DHCP server from the school, but that's where it got the gateway from. Only one interface per computer should have a gateway. So when you put a gateway in, what it's really doing is it's modifying your routing table. So all these networks attached to the public interface was done automatically. So we're not going to worry about those ones. We're not going to worry about the loopback networks. What we're going to worry about is these networks right here. So basically, router A knows about this network, 172.16.0.0/20. That's the network right there. It also knows about 172.16.16.0. That's this network right here. So for this network, this is the IP assigned to the interface. You know it's an IP because the subnet mask is fully masked off. So if it's fully masked off, it is a host address, meaning it's a single IP. If it has a subnet mask that's not all turned on, you know that is a network. So this is a host address, an IP address for our interface. This is the network that it belongs in. And this is the broadcast address for that network. And for our other interface, it's part of this network. Here's the IP assigned to that network. And this is the gateway for that network. Not the gateway. This is the broadcast address for that network. So what this routing table is doing, it's telling me how to get to the other networks. So right now, router A knows how to get to the internet. Router A knows how to get to any IP in this subnet. Router A or R1 knows how to get to any IP address in this subnet. So basically, this is what R1 knows about, or router A. Subnet 1 network, subnet 0 network, the subnet 1 network, and the internet. So what happens when a packet comes to this router? It tries to get a match in this routing table. And as soon as it finds a match, that's the route it takes. If it doesn't find a match, this matches everything. This is the gateway of last resort. So if it is going to try to find a match in the routing table, and if it doesn't find a match, it's going to send it out to public interface. So if a packet comes to this router, let me go over here. If a packet comes to this router, I don't care if a computer over here sent a packet, a computer over here sent a packet to this router, and it's destined for an IP in this subnet, 172.16.32.0/20, it's going to try to find a match. Does this match 172.16.32. something? No. This one doesn't match either. This one doesn't match. This one doesn't match. This one doesn't match. This one doesn't match. And it's going to go all the way through. These are multicast addresses. I don't want to go into that right now. So it's not going to find a match for any route in this routing table for the 172.16.32.0 network. Nor will it find a match for anything in this network. So if it doesn't find a match, it's going to send it out the default gateway, which means out the public interface. So if someone sends a packet from any network to here or here, this router doesn't know how to get to subnet 2 or 3. If a R1 receives a packet for subnet 2 or 3, right now it's going to send it out the default gateway, and it's never going to reach its destination. We can also look at the routing table by typing route print. And I can see my routing table there as well. Essentially the same information. There's the 172.16.0.0 network, the 172.16.16.0 network, 172.16.16.0 network, but it doesn't know about 32.0, and it doesn't know about 48.0. The command again was route print. So our next lab is going to be configuring this routing table. We want to go through to how to read the routing table and how to add routes to the routing table. We need to tell R1 about subnet 2 and 3. R1 will only know about networks it's directly attached to. I haven't looked at this yet, but R2 will only know about subnet 1 and subnet 2 because it's directly attached. So we need to tell R2 about this subnet and this subnet. And R3 will only know about subnet 2 and subnet 3. We need to tell R3 about subnet 1 and subnet 0. The routers right now only know about the networks that they're directly attached to. So we need to tell each router how to get to these remote networks. And also R2 and R3 don't know how to get to the internet yet. We need to tell R3 to get to the internet, you send your packets to R2. We need to tell R2 to get to the internet, you need to send your packets to R1. R1 knows how to get to the internet because R1 has a default route, that quad 0 route. So that will be the next video, how to set up the routing table. That's it for right now. Thank you.